In this video, we are going to find out the center of mass of the semicircular disc. Now you can see the semicircular disc here. If this disc would have been a complete disc, then the center of mass would have been at this point, at the geometric center. Okay, I am denoting this geometric center as a origin, OO. And this is the radius of the semicircular disc, that is R. Now, this semicircular disk's center of mass would be lying somewhere on this line, this dotted line you can see. Okay, so why? Because the left half and the right half are symmetric about this axis, so it should be lying somewhere on this line. Okay, but here we cannot say it lies exactly in the middle because it is not equally distributed above and below, so we cannot say exactly at the middle. We have to find out that. But before we do find out the center of mass of this semicircular disk, I want to go back and I want to recall that we have already found out the center of mass of a semicircular wire. Okay, if you remember, you can see the previous video that if a radius r is there for a semicircular wire, then its center of mass is at 2r by pi height from the origin, or from the bottom, you can say. So this is the important information that will be useful for us. Now let's come here. Okay, and let's find out the center of mass of this. So at the back of the mind, you should know that for a semicircular wire of a radius r, the YCOM is 2r by pi. That is the location of the center of mass from the bottom, right? Okay. So now what we will do here is, the basic idea is that this semicircular disc can be divided into many semicircular wires. Okay, many semicircular wires of very thin thickness. Okay, very small thickness. So let me draw here such a semicircular wire. So I am taking a semicircular wire like this. It is very small thickness. It has very small thickness. Okay, let's say it is at a height y. It is at a height y, and let's say this thickness is dy. Let's say this thickness is dy. Correct. So let me write it here. This thickness is dy thickness. So let me write it separately over here, then you will be able to understand very easily. So here, this is the semicircular wire, you can see. Pardon my drawing. Okay, so this thickness is dy, and what about this length? This length will be pi into y, because see, I am taking the radius of this semicircular wire as y. So this length will be half of the circumference, that is pi into y, right? That is pi into y. So the area of this semicircular wire, let's call it as dA. That is equal to, what will be the area of this semicircular wire? That is dA. That will be equal to this length into this breadth. You can see this as a rectangle, right? If I stretch it in this manner, okay, if I stretch it in this manner, this length is pi y and this thickness is dy. Okay, so here the area dA will be pi y into dy. That is the length into breadth, pi y into dy. This is the dA, right? So now what we will do is, we will find out the mass of this small thickness. So to find out the mass, we should know the mass distribution of this. So we are assuming this is a uniformly distributed mass. So let's say sigma is mass distribution for this disk. The mass of this disk is m and the area is a. So sigma is equal to m upon pi r square for whole disk. Okay, the full disk, but this is area, right? Pi r square by 2, that will be, so this will be 2 over here, right? So similarly, the sigma will be written as dm by dA. So dm can be written as sigma times dA. So sigma is 2m upon pi r square into dA. What is dA? From here you can see dA is pi y dy. So this is pi y dy. So you can find, cancel this pi, you will get 2m by r square y dy. This is dm. Okay, right, so we got dm. So now let's find out the center of. Now what we will do, we have got the center of mass of this semicircular wire. So I have told you how to find it. It is at the height 2y by pi, right? So this is the height of the center of mass for this semicircular wire. Now what we are going to do is that we are going to find out the semicircular center of mass of all the semicircular wire from here, like this, like this, like this, like this, for all semicircular wires. And then we will find the center of mass of all the center of masses, all the individual center of masses. Okay, so then we have to integrate, right? So we know the integration for calculating the COM, YCOM. So YCOM can be calculated as y dm upon integral dm, where y is the location of that particular mass. Okay, dm mass. Now here the center of mass of each small ring is at height 2y by pi. So here instead of writing y, I will write 2y by pi, because the location of that mass dm, see, the location of that mass dm can be thought of as if it is located at this height instead of all this, right? Because this is the height of center of mass. So for this semicircular ring of mass dm, you can say that the dm mass itself is located at 2y by pi. So on such 2y by pi's we have to integrate. So instead of y, I will write 2y by pi. So let me erase this, and I will write here 2y by pi. Now I will integrate. So this dm integral is m in the denominator. So this integral 2y by pi into dm, sorry. So what is dm? Dm is 2m by r square into y dy. This is dm. So this is integral 2y by pi. Dm is 2m by r square y dy. This is equal to, now you can see if m can come out, 4m by pi r square can come out, 4m by pi r square can come out, and there is another m already in the denominator. So you have to integrate over y square dy, right? So the integral will be from 0 to r, right? So this is 0 to r, the radius. So the 0 to r we will integrate. So this m and m will basically cancel out. So this is 4 upon pi r square. This is y cube by 3. And the integral limits are from r to 0. So this will become 4 upon pi r square into r cube by 3. Correct? So r square will cancel out with this one. So you will get answer as 4r upon 3 pi. So the center of mass for the semicircular disc is at height 4r by 3 pi from the bottom, from the horizontal, or you can say from the origin. So from the origin at the radius, at the distance 4r by 3 pi. Okay, this will be the height of the semicircular, height of the center of mass of the semicircular wire, semicircular disc, not wire, semicircular disc.